This video contains the solution for problem number 1, the 2009 AP Calculus BC free response question, form B. And we may use our calculator if we choose, and we will. So let's see, we've got a graph here, x and y, we've got a region here, R, and that's 0 to 30, goes up to 20, so let's see what we have. Baker is creating a birthday cake. The base of the cake is the region R. In the first quadrant, under the graph of y equals f of x for 0 to 30, the function is given by 20, that's the amplitude, sine of pi over 30x, so the period of the whole thing would be 60, right? So that's half of it. Both x and y are measured in centimeters, okay? The region R is shown in the figure above, and the derivative of this, as if we didn't know how to do that, is given right here. Of course, we do know how to do that. Usually when they give something like this, it's because they don't want you to miss the problem just because you messed up the derivative. So I'm sure we'll need to use that. Of course, we could have found that, and it's just derivative of sine is cosine, and then you multiply it by the derivative of what's inside, which is pi over 30, because you 2 pi over 3. So I'm surprised a little bit that they gave that. So, part A. The region R is cut out of a 30 centimeter by 20 centimeter. That would be like this. Rectangular sheet of cardboard, and the remaining cardboard is discarded. They want us to find the area of the discarded cardboard. Well, the piece of cardboard is 20 by 30, so that's 600 square centimeters, and we're cutting that out, so it'd be 600 minus that area. Let's do that. So 1A, our area is 600 square centimeters minus the area from 0 to 30 underneath the curve 20 sine. This is the regular function, right? We're not involved with the derivative yet. 30 dx, and I'm going to go ahead and use my calculator for that. Maybe you could do it without, but this is the calculator part, so take advantage of that. So let's see, 600 minus math 9, that's fn int, 20 sine pi over 30 x. Remember, your calculator follows order of operations, so this is actually equivalent to what we want, right? That x is not on the bottom of that fraction. You could put the fraction in parentheses if that makes you nervous, but that is correct. And comma x, comma 0, comma 30. Just check my parentheses. That's the beginning open, and then that's the open of the sign, the close, so that looks good. And I'm just going to go ahead and make sure that I'm in radian mode because I'm doing calculus. And that gives me, what, 218.028. And this is a word problem, so we should include units. This is an area, and those areas were, or the lengths were given in centimeters, so this is square centimeters. Part B. The cake is a solid with base R. Cross-sections of this is an interesting cake, isn't it? Cross-sections of the cake perpendicular to the x-axis are semicircles. So, interesting indeed. It's supposed to be a very talented baker. There are semicircles. If the baker uses 0.05 gram of unsweetened chocolate for each cubic centimeter of cake, how many grams of unsweetened chocolate will be in the cake? All right, so at the end we'll have a little dimensional analysis, looks like. So here's our region from 0 to 30. The cross sections are perpendicular to the x-axis, and each one of those cross sections is the diameter of a semicircle. And that's the value of the function, right? That's the 20 sine pi x over 30. that's the diameter, right? So if we want the area of this, the area as a function of x is 1/2 pi r squared. It's not the whole circle, it's just a semicircle. So that's 1/2 pi times, and this is the diameter. The radius would be half of that, right? So that's 10 sine pi over 30x. And that's the area function. So when we find this kind of volume, we want to find the integral from 0 to 30 of the area. Now look, I've got a 1/2, a pi, and a 10. That's 5 pi. You could, if you wanted to, move this to the outside. You could just enter it exactly like that in here. It really doesn't matter. But I'm going to move it out there. So then on the inside I have sine pi over 30 x dx, and that will give me my volume. So let's see if we can get that. So I have 5 pi times math 9 f to fn int sine pi over 30 x comma x comma 0 comma 30. And I feel like I've done, oh, I know what I did wrong. Hold on. I don't like that. This is supposed to be 1/2 pi r squared. We didn't square that. That would make that a 100, so that would change this to a 50. Honestly, I don't know why. I just had a creeping feeling something was wrong there. Maybe that happens to you sometimes too. But lucky we caught that. So that's 100 now times 1/2. So that'd be 50 pi on the outside, and this would be that expression squared. So let's go back and fix that. So let's see if I can do that by, editing this. So I need another set of parentheses around the whole sine function, and then square that whole thing. Oops, that's the wrong way around. So let's see, close parentheses and then square it like that. And now I think we're good to go. So, and then now there's still just 5 pi. So go back and fix that too. Insert a 0. There we go. That looks right now. That gives us a volume of 2,356.194 cubic centimeters. Okay, and they want to know about grams of chocolate, so let's just check that again. 0.05 grams per cubic centimeter. So 0.05 grams per cubic centimeter, and I have cubic centimeters. So if I multiply by that, 0.194, the cubic centimeters cancel out and I get grams of chocolate. So I think I still have that answer here. I'll just go ahead and multiply that by 0.05, and that looks like 117.810 grams. All right. And last, they want us to find the perimeter of the base of the cake. This is the base, so that perimeter. That would be this distance, which is 30 centimeters, plus this arc length. So let's see if we can set that up. The flat part on the x-axis is 30, plus the length of the curve from 0 to 30. And to find the length of a curve, our formula is 1 plus dy dx squared. So 1 plus, and hey, that's why, look, there it is. They gave it to us. Not that we couldn't find it, but might as well use what they gave us. So 2 pi over 3 cosine pi x over 30 squared dx. So that's going to be a lot of parentheses in the calculator. I'll have to be very careful there. Let's see if we can do it. Move that up there so you can see. Hopefully see the calculator screen also. So let's see. We've got 30 plus math 9, an int, the square root of 1 plus, and then big set of parentheses around this whole thing. Parentheses 2 pi over 3 cosine of pi x over 30. That closes the cosine function. That closes the 2 pi over 3 yada yada yada. And that last one closes the square root sign. If you've got a fancier TI-84, it might give you the square root bar. That makes it a little bit easier. Okay, so I think I'm good for parentheses there. Comma x, comma 0, comma 30. And I added in the 30 already, so and we wouldn't have expected it to be like horribly bigger than 30 because, after all, we're talking about this. Sorry, let me come back down to the picture. We're talking about this plus this. So, although this is clearly longer than 30, it shouldn't be like orders of magnitude longer than 30. So that seems like a pretty reasonable answer. 81.804. And remember your units. This is just a perimeter, so that is centimeters.